Hello everybody. Now we'll have a discussions regarding the types of stresses. Now we have already studied the stress, strain, force. Now what do you mean by the stress? The word itself creates a stress in our mind. Many times we are saying, I am very stressful today. What does it mean, stress? Anybody can say that is stress is equal to force upon area. Okay, it's correct. But what is exactly the meaning of stress? What are the different types of stresses are there? How to identify which stress a component belongs to? How the component is being felt by what type of stress? What are the different types of strains are there? Everything we'll discuss in the next few slides. Now basically stress is being classified into the two category: normal stress and shear stress. No any other category of stress is available in the universe. Normal stress and shear stress, always you should remember, stress is being classified in two category: normal stress and shear stress. Normal stress is being classified into the two subclasses: tensile stress and compressive stress. Now tensile stress, both are normal stresses. Tensile and compressive both are normal. And shear stress is being classified into two category: direct shear stress and torsional shear stress. Then some of you may say that what is bending stress? Bending stress is the combination of tensile stress and compressive stress. It is not any other stress, it is a part of a normal stress. Then direct shear stress and torsional shear stress both will fall under the category of shear. Now how to define a normal stress? When the direction of force is perpendicular to the area of failure, then the type of stress induced in the component is called as a normal stress. When what is the shear stress? When the direction of force is parallel to the area of failure, then that type of stress is called as the shear stress. That means if force is a perpendicular to the area, then it is a normal stress. If force is a parallel to the area, then it is called as the shear stress. Now in tensile stress, direction of force is perpendicular to the area, but it is in tensile in nature. It is a pull in, pull out. There are two categories are there. If it is a pull out is there, then it is a tensile. If it is a pull in is there, then we can say it is a compressive stress. Then in shear stress category, two categories are there: direct shear and torsional shear. Now direct shear means the force is parallel to the area of failure. Both forces will be parallel, shearing force will be parallel to each other, and that will go for a dislocation. Then torsional shear, the twisting movement will be there, the torque will be available for the torsional shear. Now here onward in entire design engineering, you should remember two stresses. Again I will repeat, only two stresses are available. One is the normal stress and second is the shear stress. Normal stress is being classified in two categories: tensile stress and compressive stress. Shear stress is being classified in two categories: direct shear and torsional shear. Next one. Now we'll see in pictorial view how the stresses and their area of failure are available. Now let us see. This is a tensile stress. Now see, this is a P is the direction of force is there, in it is being pulled out in the both the direction. If I have taken a section at this location, just see section at this location, this force is going outside, this force is going outside. Due to the force, this is the failure area, this is the area of failure, the area is going to get fail. Now see, direction of force is perpendicular to the area of failure, therefore stress is calculated as the force upon area. That is P is the force and area, whatever may be the area. If it is a rectangular section is there, then width into the height. If it is circular section, in that will be pi by 4 into d square is there. Then deflection of such area will be calculated as P into L divided by A into E, that we are aware about it. Then next one is the second part in the normal stress is nothing but a compressive stress. See the direction of forces, it is a compressive. Here direction of forces is pull out, this is the pull in is there. This is the area of failure, how it is going to fail. It may get failed by bending. Now this is the sigma c, force upon area. And then again deflection is calculated as A into L divided by A into E. Sorry, this is the P into L divided by A into E. Then second category is there, that is of shearing stress, shear. Now see direction of forces. This is the force 1 and force 2. Both are pulling outside. Now what will happen about this bolt? Okay, this will get sheared out. Sheared out means that will get cut at the portion. If you see in the forces direction, that will be in this direction. This portion it will get dislocated. That dislocation will create a shearing. Shearing will be equal to the force divided by area, that is tau. This is a tau force, tau divided by area. Then this is a strain, shear strain, tau divided by g. G is nothing but our modulus of rigidity. E is equal to 2 into g divided into 1 into mu. 1 plus mu is there. Now this is entirely regarding the shear stress and normal stress. I think the stress category will be clear to us. Now let us see bending stress. What is exactly the bending stress? Bending stress is not a new stress, it is a combination. It fall in the one family of a normal stress. Normal stress will have a two subcategory, that is the tensile stress and compressive stress. Bending stress will consist of both the cases. It will have a tensile stress as well as a compressive stresses. Now let us see. That bending stresses will be calculated by using a formula m by I is equal to sigma by y is equal to E by rho. Therefore, bending stress you will get m into y divided by I. What is y? Y is the distance of end fiber. Distance of end fiber from the neutral axis. I is the mass moment of inertia. Then torsional stresses are calculated as T by J is equal to tau by R is equal to G theta by L. Therefore, tau will be equal to the T into R divided by J. T is torque, R is the distance of end fiber, and J is the polar moment of inertia. Then angle of twist is calculated as T by J is equal to tau by R is equal to G theta by L. From this formula you will get theta is equal to T into L divided by G into J. Now this is the typical example of a eccentric loading is there. Now suppose a shaft or rod is available. I should not say it is a shaft, I will say it is a rod is available. It is force is being applied at a distance of E, it is eccentric. Now whenever I am going to apply a force at the center point, it is the centroidal axis is there, then stress developed in this type of section will be equal to the force divided by area, that is P divided by area. But this is applicable, this is the portion, therefore it is being classified into category, that is the force is passing to the centroid, plus it will create a bending moment. These two bending moment will be equal and opposite, therefore it will get cancelled. Therefore totally it will carry a force, stress plus bending stress. Therefore the total stress in such a component will be equal to the P divided by A plus P into E divided by I. That is the bending stress. This is entirely regarding the different type of stresses. Now let us see once again what are the different stresses are available. Two stresses, normal stress and shear stress. Normal stress is being classified into category tensile stress and compressive stress. Shear stress is being classified into category direct shear and torsional shear. Now proceed for the next portion, that is the different standards and codes. Now what is the use of standards and codes in the design engineering? Now we cannot design any component as per our wish. If that is the traditional design process. If we are designing as per our wish, it cannot be a standardized. If I am going to manufacture a vehicle as per my own standard, then it may not be sustainable in the market because it is not being prepared by standardization. I will prepare my own spark plug with the different dimension, nobody others are manufacturer of that, then nobody will purchase that vehicle. Therefore, the standards and codes is having a much more importance in the design engineering. That is, it is, we'll see the definition, that is the standards. It is defined as obligatory norms to which various characteristics of a product should be conform. That means these are the central standards are written according to the standards. We are going to follow to the standards. Okay, these are obligatory norms, we have to follow it. Now we are switched to the BS6. BS6 is based on the European standard. We have to follow to them, because otherwise if you are not going to follow, then we may go for any type of emission norms, no, as per our requirement. Therefore we should be able to stick to the certain international standards. Then characteristics include material dimensions and shapes. Now there are different standards are available, like ANSI, American National Standard Institute, it is the ANSI. Sorry, ASME standard, American Society for Mechanical Engineers. ASTM standard, that is American Society for Testing of Materials, international standard. GIN standard is the Japanese standard, Japanese industrial standard. NDT standard, non-destructive testing standard. Different standards are available, like a BS standards are there. Bharat Stage 4 standard, it is the BS standard is there. ISI standard is there. This is the Indian standards are there. Now there are some codes are available. Now whenever our component is there, that component is also being designed based on the different types of codes. Each and every country will have their own coding system is there. For some standard product like a pressure vessel, US standards are there, or many of the MNCs are working on the based on those standard. As a mechanical engineer, we should know all types of codes and their standards. Now codes are the rules having the protection from law by the government. It is being protected by the every country. Like ASME codes for the design of shaft, this is a standard process. The codes are strict in their definition. Any system or collection of rules and regulation will define the codes. Now the standards can be defined as per the different hierarchy. Some are called as a company standard, national standard and international standard. Now company standard is going to follow to the national standard. National standards are going to follow to the international standards. I will give an example. We are using a scale. That scale is being calibrated. Okay, how the scales are being calibrated? Now we are having a one national standard is there. That national standard is going to follow the scale which is available in the Paris. That is called as the international standard. Likewise, that is 1 centimeter is equal to 10 mm. That is the international standard. Accordingly, we will get a scale which is being manufactured. Therefore, every standard is subset of other standards. Now we have discussed regarding the type of stresses and different codes and the standards. Thank you.